Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video, we're going to learn to solve absolute value inequalities where the absolute value is greater than a positive number. Like in problem 7, we have absolute value of x plus 6 is greater than or equal to 12. Think about what types of numbers have absolute values that are greater than or equal to 12. Well, big numbers, right? Numbers that are greater than 12, that's one type of number that does that. So when we split this into two inequalities, one of our inequalities will be x plus 6, the expression inside the absolute value, being greater than or equal to 12. Or there's going to be a second inequality that comes out of this, and that comes from the numbers that are really on the negative side, negative 13, negative 14, negative 100. Numbers that are less than negative 12 will have an absolute value that's greater than 12. So that would be x plus 6 is less than or equal to negative 12. Now before we solve this, a little bit about what we've done with absolute values. So let's say we have absolute value of x equals some number a. On the number line, that would be a and negative a on each side of 0 are the two solutions. Anything in between those two, this is where the absolute value of x is less than a. And really what that means is that the distance between x and 0 is less than a units. Anything outside of there is where the absolute value of x is greater than a. And that's true on either side. So when we're doing a greater than inequality like we have here, there's two pieces that we're looking at. The piece on the right-hand side and the piece on the left-hand side. Not necessary, but you could also solve these by using test points, kind of like what we did in quadratic inequalities. You could find the critical values, find where the absolute value of x plus 6 is equal to 12, put those on the number line, pick 1 point from each interval and try it. Not a bad solution. All right, back to the problem at hand. The first equation, inequality, we can solve by subtracting 6 from both sides. X is greater than or equal to 6. The other one will subtract 6 from both sides, and we end up with x is less than or equal to negative 18. So in set builder notation, it's a set of all x such that x is greater than or equal to 6, or it's less than or equal to negative 18. On a number line, the endpoints are included, so we're going to use square brackets. Greater than or equal to 6 starts at 6 and goes to the right. Less than or equal to negative 18 starts at negative 18 and goes to the left. So it's going to look something like that. In interval notation, that would be negative infinity. Remember the left arrow goes with negative infinity, comma negative 18 bracket, union, bracket 6 comma infinity. Now the other problem at the bottom of the screen, the absolute value there is not isolated yet. So that's going to be our first step, and then solving will be just like solving the first one. We have absolute value of 4x minus 2. Minus 5 is greater than 9. So we'll add 5 to both sides of the inequality. Absolute value of 4x minus 2 is greater than 14. Because we have an absolute value greater than a positive number, we split this into 4x minus 2 is greater than 14, which is basically what we had there without the absolute value bars, right? Just drop the bars. That's your first inequality. For the second one, take 4x minus 2, and we change the sign from greater than to less than, and we replace 14 by its opposite, negative 14. Okay. To solve the first one, add 2 to both sides of the inequality. 4x is greater than 14 plus 2, or 16. Divide through by 4. 16 divided by 4 is 4, so we have x is greater than 4. For the other one, when we add 2 to negative 14, we get negative 12, so 4x is less than negative 12. And when we divide both sides by 4, negative 12 divided by 4 is negative 3. So we have x is less than negative 3. The set of all x such that x is greater than 4 or x is less than negative 3. Basically copying that line right down. Let's take a look at the number line. Here we're going to use round parentheses because there's no equal sign under the inequality sign, so the endpoints are not included. Ooh, I've got those backwards, huh? Negative 3, positive 4. So less than negative 3, parentheses, shade to the left of negative 3, greater than 4, parentheses, shade to the right. Okay. Interval notation, that would be negative infinity, comma, negative 3, union, 4, comma, infinity, all in parentheses. The most important thing to remember here for all these absolute value problems that we've talked about so far is what's that first step? Once the absolute value is isolated, what do we do? When you have an equation, you split it with the expression equal to the number and its opposite. When you have a less than sign, you trap that expression between the number and its opposite. And when you have a greater than sign, like the ones we did in this video, we're always working towards the outside. Greater than that number or less than its opposite. Some note cards would be really helpful here. And on the front of one note card, you could have something like this, absolute value of x greater than a. And on the back, you could write x is greater than a or x is less than negative a. That's one card. And then you can make another one for less than a and equal to a. I think it's a good idea. We'll see you in the next video.